So we say they are in a superposition of different states. And only when you measure them, for example, measure what energy they have, do you kill off that superposition.
The universe has a way of pulling you into its mysteries, like a whisper from the cosmos that you can't ignore. Imagine standing on the edge of reality, staring into a void where time itself bends, twists, and maybe, just maybe, turns back on itself. This isn't science fiction. It's the frontier of quantum physics, where experiments are unraveling truths so strange they make your heart race and your mind spin. In 2019, scientists in a Moscow lab did something that sent shockwaves through the scientific world. They used a quantum computer to make tiny particles appear to move backward in time. Not just a clever trick, but a deliberate reversal of their natural evolution, as if the universe's clock could be wound back. When physicist Brian Cox spoke about this, his voice carried a mix of awe and caution, warning that these discoveries might mean the past isn't as fixed as we think. The implications are staggering. Could the future reach back and rewrite what's already happened? This is the story of that experiment, the mind-bending quantum phenomena it's tied to, and the haunting question it leaves us with. What if time isn't the straight line we've always believed it to be? Picture a lab in Moscow, humming with the quiet intensity of discovery. The year is 2019, and a team led by physicist Gordy Lesavik is huddled around IBM's quantum processor, a machine that doesn't think in zeros and ones like your laptop, but in the ghostly language of quantum bits, or qubits. These qubits exist in a surreal state, a superposition where they're everything and nothing all at once, alive and dead, here and nowhere, until you look at them. The team starts with these qubits in a pristine, ordered state, like a row of dominoes standing tall before the fall. Then they let the qubits evolve, tumbling into a chaotic mess, like those dominoes crashing into a scattered heap. But here's where the story takes a turn into the uncanny. They apply a special algorithm, a precise quantum nudge, and watch as the qubits unscramble themselves, rewinding to their original, orderly state. With 2 qubits, they pull this off with an 85% success rate. With 3, it's still a remarkable 50%. It's as if they've convinced the dominoes to leap back up, defying the chaos, defying time itself. This wasn't just a parlor trick. It was a defiance of nature's rules. In our everyday world, things fall apart. A glass shatters, coffee spills, and you can't unmix the cream from your morning brew. This is the second law of thermodynamics, the relentless march of entropy that says disorder always wins. For a single electron to spontaneously rewind its chaotic dance, you'd need to wait longer than the universe has existed. Yet in that Moscow lab, the impossible became real, not by chance but by design. The researchers forced the qubits to defy entropy, to retrace their steps, as if time itself had been persuaded to flow backward. But before you imagine sending a letter to your younger self, there's a catch. This wasn't about changing history or sending messages to the past. It was like playing a video of spilled paint in reverse. Mesmerizing, but the paint stays in the can. The experiment didn't rewrite the past. It reversed a process in a tightly controlled quantum system. Still, the world couldn't help but catch fire with the news. Headlines screamed about time travel, about quantum computers unlocking the secrets of history. The media painted a picture of a universe where the past could be undone, where regrets could be erased. But the scientists were clear. This was no time machine. It was a breakthrough in control, a glimpse into the quantum world's strange rules, where time doesn't always play by our expectations. Brian Cox, with his knack for making the cosmos feel personal, described it as something rather extraordinary. In his lectures, he's spoken of quantum systems that seem to know about future measurements, as if particles are whispering secrets across time. He's careful, though, not to let the wonder slip into fantasy. The past isn't as fixed as we might think, he said, at least at the quantum level. But what does that mean? To understand, we need to dive deeper into the quantum weirdness, where experiments have been bending our sense of reality for decades. Take John Wheeler's delayed choice experiment, a thought experiment turned real in labs across the globe. Imagine light from a distant quasar, billions of years old, streaming toward Earth. As it passes a massive galaxy, it bends, splitting into two paths due to gravitational lensing. When it finally reaches us, we decide, right then, how to measure it. As a particle, taking one path, or as a wave, dancing across both. Here's the kicker. Our choice, now, seems to decide what the light did billions of years ago. It's as if our present action reaches back across eons to shape the past. Wheeler himself, a giant of physics who worked alongside Einstein, put it hauntingly. Does this mean the past has no existence except in the records of the present? The idea is dizzying, like realizing the story you're reading might change based on how you turn the page. Then there's the delayed choice quantum eraser, an experiment that pushes the weirdness even further. In 1999, scientists set up pairs of entangled photons, particles so deeply connected that measuring one instantly affects the other, no matter how far apart. One photon zips through a double-slit setup, hitting a detector screen, while its partner takes a different path. Here's the mind-bender. How we measure the second photon, after the first has already hit the screen, determines whether the first photon behaves like a wave or a particle. It's as if the future measurement reaches back to rewrite the first photon's story. But there's no paradox, no actual rewriting of history. The effect only shows up when you sort the data later, like finding a hidden message in a book you've already read. The universe, it seems, is playing a clever game, weaving past and future in ways we're only beginning to grasp. These experiments aren't fringe science. They're being debated at places like MIT, Caltech, and Oxford. Even CERN, home of the Large Hadron Collider, has weighed in on what this means for our understanding of time. Yakir Aharonov, one of the most respected quantum physicists alive, has proposed a radical idea called the two-state vector formalism. In his view, quantum particles aren't just pushed by the past, they're pulled by the future too. His team's experiments using delicate, weak measurements that nudge particles without collapsing their quantum state suggest that future choices might leave faint echoes in the present. It's not about changing the past, but about a universe where time is more like a tapestry, with threads of cause and effect woven in both directions. Cox, reflecting on this, has called it a challenge to our classical intuitions about causality, a hint that reality might be far stranger than we've dared to imagine. But the story doesn't stop at physics. It spills into the realm of human experience, where the mysteries of time touch something deeply personal. In the 1970s, the CIA poured millions into a secret program called Stargate, investigating whether people could see distant places or future events through a process called remote viewing. At Stanford Research Institute, researchers tested precognitive remote viewing, where subjects described targets that wouldn't be chosen until after their descriptions were complete. The results were tantalizing. Some statistical hits were so strong they defied chance, leading one reviewer to compare them to evidence in medical science. Yet skeptics argued the data was too vague, too inconsistent to be actionable. The program was shut down in 1995, but it left behind a question that lingers like a ghost. Could human consciousness somehow tap into the same quantum strangeness that lets particles dance across time? And then there are the stories we all know, dreams that feel like glimpses of the future. From Abraham Lincoln dreaming of his own death to ordinary people waking with visions of events that later unfold, these experiences carry a weight that science struggles to explain. In the 1960s, the Maimonides Dream Laboratory tried to capture this magic, testing whether dreams could predict or connect to distant events. Their results were mixed, often fading under scrutiny, but the stories persist. They tug at us, suggesting that maybe, just maybe, our minds are brushing against something timeless, something quantum. As we stand on the edge of these discoveries, the question isn't just about particles or computers, it's about us. Are we bound by time? Or are we, like the universe, something more? The universe doesn't just hold secrets, it dares us to chase them. Standing on the edge of quantum physics, where particles seem to whisper across time, we're pulled into a deeper mystery. What if our own minds, our dreams, our instincts are somehow tangled in this cosmic dance? The Moscow experiment, with its quantum computer rewinding tiny bits of reality, was only the beginning. It cracked open a door to a world where time might not flow in a straight line, where the future could cast shadows on the present. But what happens when we step beyond the lab, away from qubits and algorithms, and into the realm of human experience? Stories of precognition, government experiments, and dreams that seem to predict the future tug at our curiosity, urging us to ask, are we too part of this timeless puzzle? In 2011, a respected psychologist named Daryl Bem shook the scientific world with a paper that felt like a thunderclap. Published in one of psychology's top journals, his study wasn't tucked away in some obscure corner. It was peer-reviewed, rigorous, and impossible to ignore. Bem ran 9 experiments with over 1,000 people, testing whether our minds could sense the future. In one, students recalled words better if they studied them after the test, as if future practice reached back to help their memory. In another, participants guessed where erotic images would appear behind virtual curtains, with the locations chosen randomly by a computer after their guesses. Shockingly, they were right more often than chance could explain. Bem called it retroactive facilitation, a fancy term for something that feels like magic, the future nudging the present. The scientific community erupted. Critics cried foul, questioning his methods, while others whispered that these results could upend everything we know. Bem welcomed the scrutiny, sharing his protocols for others to test. Some labs found hints of his results, others didn't. By 2016, a massive analysis of 90 experiments across 14 countries showed a tiny but stubborn effect, too strong to dismiss as mere chance. Yet skeptics argued it could be a statistical fluke, a quirk of human bias. The debate rages on, but Bem's work left a mark, a question that lingers like a half-remembered dream. Can we really feel the future before it happens? Then there's something even stranger, something that hits closer to home. Presentiment, the idea that your body knows things before your mind does. In the 1990s, researchers like Dean Radin started watching people's heart rates, skin responses, even brain waves as they viewed random images, some calm, some shocking. The twist? Their bodies reacted before. The images appeared as if they sensed the emotional jolt coming. About 5 to 7 seconds before a disturbing photo flashed on the screen, heart rates shifted, skin prickled, brains lit up, different from when a neutral image was coming. This wasn't a one-time fluke. Labs around the world using different setups saw it too. A 2012 analysis of 26 studies found a small but undeniable effect, stronger in the best-controlled experiments. The researchers were cautious, insisting this wasn't supernatural, just a mystery within nature's rules. Maybe our brains pick up subtle cues we don't consciously notice. Or maybe it's something deeper, something quantum. Critics point to possible flaws, randomization errors, data quirks, but the data keeps whispering, something odd is happening, something science can't fully explain. Now imagine a room in the 1970s hidden behind government secrecy where the CIA and military poured millions into a program called Stargate. This wasn't about spies or weapons. It was about seeing the unseen. At places like Stanford Research Institute, researchers tested remote viewing, the ability to describe distant places or objects without physical access. The wildest part? Some experiments focused on precognitive remote viewing, where people sketched or described targets that wouldn't be chosen until after they'd finished. The setup was airtight. No one, not even the researchers, knew the target until the session was over. Yet some results were uncanny, with descriptions matching targets far beyond what chance could predict. In 1995, when Stargate was declassified, a panel reviewed the data. One expert, statistician Jessica Utz, said the evidence was stronger than much of accepted science. Her skeptic counterpart, Ray Hyman, wasn't convinced, arguing the hits were too vague, too inconsistent for practical use. The CIA shut it down, deeming it unreliable for intelligence. But those involved, like remote viewer Joseph McMoneagle, described time feeling fluid, as if past, present, and future blurred together. Could human consciousness somehow tap into the same quantum strangeness that lets particles seem to know the future? And then there are dreams, those fleeting, vivid stories that unfold in the quiet of sleep. Across history, people have sworn their dreams foretold events, from Abraham Lincoln's chilling vision of his own death to ordinary folks dreaming of disasters or chance encounters that later came true. In 1966, after a coal waste tip buried a school in Aberfan, Wales, killing 144 people, a psychiatrist collected 76 accounts of people who claimed they dreamed of the tragedy beforehand. One a child who saw something black sliding down a mountain. These stories grip us, feel undeniable, yet science struggles to pin them down. In the 1960s, the Maimonides Dream Laboratory tried, testing whether dreamers could see distant or future events. Some results hinted at success, but attempts to replicate them often fizzled. Our brains are pattern hunters, primed to spot connections after the fact. Dream of a plane crash, hear about one the next day, and it feels prophetic. But what about the thousands of dreams that don't match anything? Confirmation bias weaves a powerful spell, making coincidences seem like destiny. Still, the sheer volume of these stories, their emotional weight, keeps the question alive. Are our dreams brushing against something beyond time? What ties all this together? Quantum experiments, precognition studies, secret programs, haunting dreams, is a sense that time might be more than a one-way street. Physicists like Yakir Aharonov, with his two-state vector formalism, suggest the universe might work like a conversation between past and future, each shaping the other in ways we can't fully see. His experiments with weak measurements show particles carrying faint hints of future choices, like echoes from a time yet to come. But these aren't messages you can read or history you can rewrite. The universe seems to guard its secrets, ensuring no paradoxes, like warning your past self, can break reality's rules. Philosopher Hugh Price argues our resistance to this idea is more emotional than logical. Physics, after all, doesn't care about our sense of time's arrow. Its laws often work just as well backward as forward. Maybe we're the ones stuck in a linear mindset, blind to a universe where cause and effect dance in both directions. As we wrestle with these ideas, we're left with a feeling that's both thrilling and unsettling. The quantum world, with its particles that seem to know the future and the human experiences that hint at time's fluidity, pull us toward a truth we can't quite grasp. It's not about changing the past. Not yet, maybe not ever. It's about realizing the past might not be as solid as we thought, that our place in the universe might be more connected, more timeless than we ever imagined. And as we stand here, peering into the abyss of possibility, the story isn't over. There's more to uncover, more to feel, more to wonder about what it means to be human in a universe where time itself might bend. We've journeyed through quantum labs where particles seem to defy time, through psychology experiments that hint at minds sensing the future, and into the shadowy world of government programs chasing visions beyond the present. Now, standing at the crossroads of science and wonder, we face the biggest question of all. What does this mean for us, for time, for the very fabric of reality? The idea that the past might not be set in stone stirs something deep, a mix of awe, fear, and curiosity. It's as if the universe is telling us a story, one where time isn't a river flowing one way, but a vast interconnected tapestry, woven with threads we're only beginning to see. This final chapter pulls it all together, not to give answers, but to leave you with a sense of wonder and a question that lingers. Are we trapped in time, or are we part of something far greater? The quantum world, with its eerie experiments, points to a universe where time doesn't behave as we expect. Brian Cox, with his poet's heart and scientist's mind, has called this a challenge to our deepest assumptions about cause and effect. In the Moscow experiment, qubits were coaxed to rewind, defying entropy's iron grip. In John Wheeler's delayed choice setup, our measurements today seem to shape light's path from billions of years ago. Yakir Aharonov's two-state vector formalism imagines particles guided by both past and future, like dancers moving to a tune we can't hear. These aren't just abstract theories. They're tested in labs at MIT, Caltech, and Oxford, places where the brightest minds wrestle with reality's strangest edges. But here's the truth that grounds us. None of these experiments let you rewrite history. You can't send a warning to your younger self or change a choice you regret. The universe, it seems, has a safety net, a rule called the Novikov self-consistency principle, ensuring that any dance between future and past never unravels the fabric of reality. It's as if time allows flirtations with retrocausality, but forbids paradoxes that would break the story it's telling. This idea of a consistent universe brings us to the block universe, a concept born from Einstein's relativity that feels both beautiful and unsettling. Imagine time not as a flowing stream, but as a loaf of bread, every moment, past, present, future, already baked into a single unchanging whole. Your life, your choices, every tear and laugh are slices of this cosmic loaf existing all at once. In this view, the future isn't waiting to happen, it's already there, as real as the past. Hugh Price, a philosopher of physics, says this makes retrocausality less strange. If all moments coexist, then connections between future and past are just patterns in the loaf, not violations of some sacred order. Your choices still matter. They're yours, etched into the block, but they're part of a timeless whole. John Wheeler put it hauntingly. The past has no existence except as it is recorded in the present. It's not that the past isn't real. It's that its reality is tangled with now, with tomorrow, in ways we can't fully grasp. But what about us? Our human hearts beating in this strange universe? The psychology experiments, Daryl Bem's precognition studies, Dean Radin's presentiment research, suggest our minds and bodies might sense time's deeper layers. When students recalled words they hadn't yet studied, or when heart rates spiked before a shocking image appeared, it felt like a glimpse of something beyond. The CIA's Stargate program, with its remote viewers describing targets not yet chosen, added fuel to the mystery. Yet science demands rigor, and these findings remain slippery. Statistical quirks, human bias, or subtle cues could explain them, skeptics say. The effects are small, inconsistent, not the stuff of time machines or crystal balls. Still, they nag at us, like a song you can't quite place. Maybe our consciousness, like quantum particles, brushes against time's hidden connections, catching faint echoes of what's to come. Or maybe we're just seeing patterns where none exist, our brains desperate to make sense of a chaotic world. Dreams, too, pull us into this mystery. From Lincoln's foreboding vision to the child in Aberfan, dreaming of a black slide before disaster struck, these stories carry a weight that science struggles to measure. The Maimonides Dream Laboratory tried to capture this, but their results faded under scrutiny. Our minds are storytellers, weaving meaning from fragments, remembering the dreams that match reality and forgetting the thousands that don't. Yet the sheer number of these tales, their emotional pull, keeps us wondering, what if, in the quiet of sleep, we're touching something timeless, not predicting lottery numbers or rewriting history, but sensing the universe's deeper rhythm, a rhythm where past and future hum together? As we step back, what can we say for sure? Retrocausality, as an idea, is real. Not science fiction, but a serious framework in quantum physics. Aharonov's work, published in top journals, shows particles behaving as if future choices matter. Delayed choice experiments and quantum erasers reveal a reality where time's arrow wobbles, where cause and effect blur. But these are mathematical dances, not tools for changing what's done. The past remains safe, not because it's untouchable, but because the universe weaves its story too tightly for paradoxes to unravel it. The psychological studies, the government experiments, the dreams, they don't prove we can alter history, but they hint that time might be more flexible than we thought, that our place in it might be more profound. This isn't about time travel or undoing mistakes. It's about a universe that's stranger, more connected than we ever imagined. The quantum world, with its spooky correlations and the human experiences that echo them, suggest we're part of a reality where time doesn't just march forward, it intertwines, reflects, resonates. We can't change the past, but we can change how we see it, how we fit into the cosmic whole. As Cox says, quantum mechanics forces us to let go of old intuitions, to embrace a reality that's rather extraordinary. The universe isn't just a place we live in, it's a story we're telling, One where every moment, past, present, future, is a thread in a tapestry we're only beginning to understand. So where does this leave us? With wonder, with questions, with a sense that we're on the edge of something vast. The science of 2025 pushes us further. New quantum experiments are probing deeper, exploring whether consciousness itself might play a role in reality's fabric. These aren't answers. They're invitations to keep looking, to keep feeling the pull of the unknown. The past may be safe, but our understanding of it is shifting, like stars coming into focus on a clear night. We're not just creatures of time. We're part of its mystery, its beauty, its endless possibility. And as we stand here, hearts open to the cosmos, we can't help but ask, what else is out there, waiting to change how we see everything?